Hello everyone, this is Vijay Lakshmi Sugnale and this is my YouTube channel When Maths. Here this YouTube channel helps to those which are studied first PUC NCERT syllabus. I solve the example problems, exercise problems and related theory based on the syllabus and topic wise syllabus. Here in this section we discuss the concept sets. Here we define the definition of subset, intervals and power set with example. First one is subset. Okay. Here we define subset. Before that we have to consider two sets. Okay. We have to consider the two sets A and B. Okay. Here we have to consider two sets A and B. Then definition is a set A is said to be a subset of a set B. Subset of set B if every element of A is also an element of B. Here the subset can be represented as a symbol, this one. Here I am saying A is subset of B. It means B is the larger. Okay, it containing all the elements. Then when we say A is subset, if in a set containing the all the elements of B or else the elements of B. For example, here I am considering a set B containing the elements 1, 2, 3. Then when we say A is subset, here taking or considering from these three elements, we have to make another one set. Okay, that is called the subset. By using this set, I prepare another one set, that is 1, 2, 3, as well as 1, 2, then D 1, 3, or it may be 1. Okay, these are all called it as a subsets. Okay, when we say subset, if B is a one set, by using the B set we create many sets. Okay, we write many sets, these are called the subset. It is same element, if every element of A is also subset or there is some elements taken, this is also subset. Okay, in other words what we say, A is subset of B if whenever the element A which is belongs to A, then A is also belongs to B. Okay, next, this is the example of the subset. Then one note point is there. Okay, there is a one note point. If every set, okay, if every set A is a subset of itself, every set is a subset of itself. Here A is a subset of A because that A containing every element of A, both sets having the same element, therefore we define every set is a subset of itself. Okay, next we discuss the examples. Okay, here I am writing one examples. Consider a set C. Okay, here I am taking one example. Consider the set A containing the elements 1, 3, 5, 7, 9. Write the subsets of A. Okay, we have to write the subsets of A. Here I have written subsets. A is the main set, B containing the elements 1, 3. It is also subset because these elements are present here. Then 1, 7, 3. It is also one of the subset of A. Again the empty set. Okay. Another one important concept. Empty set is always subset of every set. Okay. Empty set is always subset of the every set. Then E. The set E containing the elements 1. It is also one set. A set. If A is a set, then we have to write many subsets. Okay. Next. Again, I will consider next concept, subset of a set of real numbers. Okay. Subset of the set of real numbers. Here the concept is subset of set of real numbers. Okay. In number set, we know that real numbers. Here, there is a real number. Okay. It is the universal set. It is also called as universal set. Universal set means it containing a many sets. For example, real numbers. Real number containing the mainly rational numbers, again irrational number. Okay. Next, in that irrational numbers there are types are there. One is, what are the types of irrational number? There are two types are there. One is recurring, non-recurring. Recurring, and another one is non-recurring. Okay. In that rational numbers there are so many numbers are there, that is integers. Okay. Integers as well as fractions. Okay. In that integers we have again parts. Okay. Therefore real number has so many number sets are there. Therefore we consider real number is a universal set. Okay. Then as in that integers. Okay. In that integers, then there are two types are there. Okay. After that integers, there is a whole number, then natural number. Then in that whole number, natural numbers, then it containing a positive numbers, and positive numbers are the natural numbers and whole numbers. Here there is a negative numbers. Okay. There is a negative numbers, whole number, natural numbers, and so many numbers are there. Okay. Then we say that the subsets of real numbers, we have to write the relation here. Okay. First we considering the natural numbers. Okay. Here usually real numbers are denoted as a R, rational numbers are denoted by Q, irrational numbers are denoted by Q dash, and integers are represented by Z. Then whole numbers are represented by W. Natural numbers are represented by N. Here negative number or negative integers, it is Z minus. Okay. Then from this what we say, it is natural numbers are the subset of integers. Natural numbers are the subset of integer, because integer containing a positive numbers as well as negative numbers with 0. Here natural numbers sister, I have taken only natural numbers. Natural numbers means only the positive numbers. Here it containing positive, negative as well as 0, but natural number is the subset of integers. Again, integer is the subset of rational number, we can say. Okay, rational numbers means the numbers can be expressed in the form of p by q. All the numbers, positive numbers, negative numbers and 0 are expressed in the form of p by q. Therefore, z is the subset of rational number. Again, rational number is subset of real number. Okay, we say rational number is subset of real number because real number containing the rational numbers, because real number containing the rational numbers. Okay, then R is the mean the set, that is universal set. Then Q is the subset of real number, Z is the subset of the rational number, and natural numbers are the subset of integers. Okay, now we discuss the intervals. Okay, here the next concept is intervals. Here we discuss the intervals now. Intervals of subset of R. R means it is a real number. Usually capital R denotes the real numbers. Here it is the real number. Intervals of the subset of real numbers. Let the before going to write, intervals are usually denoted by open bracket or close bracket. Okay, here intervals are usually represented in two types. This one close bracket is open, and this one is bracket called it as a open interval. Then this one is called it as a close interval. In that open interval means the end points are not included. Here end points are not included, but closed means end points are included. Here including endpoints. Open interval means not including. Okay, here we have to consider, when we say the interval, there is a comparison between two numbers. On that time we say the intervals. Okay, here let A and B are two numbers. Here A and B are two numbers. Both the numbers are the real numbers. Here we have to consider the two numbers. Okay, both the numbers are real numbers. Then we define the interval. Here I am considering the elements or real numbers, the set of real numbers. Here let A, B, R belongs to the real numbers, and an element or a number A is always less than B. Then the set of real numbers, Y such that A is less than Y less than B is called open interval, AB. It means there is a number in between A and B, that numbers not equals to AB. Okay, there is a number in between A and B, that number not equals to A and B. Therefore, then the interval is called it as open interval. Usually it is denoted by the symbol open interval A, B. all the points between the open intervals. Here all the points between A and B belong to the open interval A comma B, but AB themselves do not belong to the interval. Here open interval means the end points are not included in this interval. Then the interval which contains the endpoints, the interval which containing the endpoints, also called it as, also it is called closed interval. It is called closed interval. Closed interval can be denoted as y, an element which is less than or is equals to y, which is less than or is equals to b, and it can be denoted by the closed interval. Therefore the endpoints are included. Okay, here the endpoints are included. Then sometimes we say semi open, semi closed. Okay, we can also have intervals. There are intervals, that is A comma B. It means when the side is closed intervals, that side we written x. The closed intervals represent, here there is a point A B. Okay, x be an element. Here this closed interval represent less than or is equals to. The open interval means that is only less than condition. Okay, here closed interval means less than or is equals to, or it may be greater than or is equals to, but here we consider A is always less than B, therefore less than or is equals to condition. It is called semi closed. Okay, it is called semi closed. Then first I have written open interval, after that I have written closed interval. It means there is an element x here for the closed interval which is less than x. This closed interval represent the less than or is equals to condition of B. Okay, always the closed intervals represented the less than or is equals to. These are the open interval and closed interval. This is semi open interval. This is semi open interval. Here the element A is included, B not included. Here A is not included but B is included. Usually in the diagrammatically we have to represent. Here diagrammatically we have to represent. Here there is a point A and B. A, B. Okay. Now closed interval means there is no elements A, B are not included. Here closed interval means the elements A, B included. Semi closed means it represents the semi. This one is equals to A but it is not equals to B. Then this is called semi open intervals. Okay, these are the intervals. Usually we have written A comma B, the closed interval A comma B, then closed interval A, B, A, B. Okay, this is the intervals. Now we have some examples. Sometimes usually in question they given as a set builder form, we have to write in the form of intervals. Okay, here I consider one example. Here example, the set x, x is belongs to R. Okay, then 5 is less than x less than or is equals to 7. It is written in set builder form. Okay, it is of the form set builder form. We have to write in that form of intervals. Here we have to write the intervals. First we have to consider the endpoints. We written endpoints now. Here there is a less than condition, that's why I put open interval. Here there is less than or is equals to, therefore we have to written close. This is the written form of the intervals. When they given in set builder form, we have to write in the form of intervals. Sometimes they given in the form of intervals, we have to write the set builder form. For example, the given intervals 6 and 2, they given the open interval 6 comma 2 can be written, it can express in the form of, in the set builder form. It can be expressed in set builder form. Okay, set builder form. The general set builder form is, we have to written set A is equals to flower bracket x. X is always written real number such that, okay, the intervals first we have to write the element 6 and 2, then x in between the interval of the element we have to write 6 and 2. After that check the interval. Here there is a open interval, therefore we written less condition. Here also open interval, we have to write less than condition. Okay, this is the set builder form when they given in the form of intervals. Okay, now the next concept is power set. Okay, the next concept is power set. We will discuss the definition of the power set now. Okay, power set means the collection of all subsets of A. Definition of power set is the collection of all the subsets of A. The collection of all the subsets of A are called it as a power set. Usually power set can be represented as P of A. Okay, always the power set can be represented as a P of A. It means power set of A. Power set means the collection of all the subsets of A. Here there is a one calculation part is there. Okay, always the number of subsets in a set A is always is equals to 2 to the power n. Here n represents the number of elements present in a set. Number of elements present in a set. In a set A. Okay, this is the number of finding the subsets of power in a set A. That is, there is a total number of subsets in a set A is 2 to the power n. For example, I will consider here there is a set containing an elements 1, 2, 3. Okay, here write all the subsets of A. Here, how many subsets are there? We don't know how many subsets are there. Then, first we have to calculate the subset now. Here, how many elements are there? There are 3 elements. Then, 2 to the power 3. Because 2 to the power n means n is number of elements. Here there are 3 elements are 2 to the power 3. It is multiplied 2 on 3 times. 2 to the power means multiply 2 by 3 times. 2 2s are 4, 4 2s are 8. Therefore, how many subsets are there? There are 8 subsets. Okay. What are those? First, subsets of A are, that is, I am considering as a B. Here, A is itself a subset. Then 1, 2, 3. Again, another subset. I consider null set. Here, null set is a subset of every set. Then D. 1. It is also subset. E. The element 2. F. 3. Then consider 2 elements. 1, 2. Again 2, 3. Then 1, 3. Okay. How many subsets are there? Here 1, 2, 3, 4, 5, 6, 7, 8. Okay. Then how many numbers? 8. Here also we written 8. Other than these elements or other than these subsets, we can write more subsets. No, we can't write. Okay, because we write 1 comma 2 other than 2 comma 1, both are equal. Okay, then 3 2 2 3, both are equal. Here every set containing the, okay, here we have to check the condition. Based on the condition, we have to write the subsets. This is collection of all the subsets are called it as a power set. Okay, collection of all the power sets are called it as the power set. Collection of all subsets of sets A is called the power set of A. Okay, then last one is universal set. Okay, already I am saying universal set. Okay, here universal set. Universal set means we have to deal all the elements or subsets of a basic set which is relevant to the particular constraint. Okay, it is a universal set means it is a basic set containing all the relevant content. Then it is called it as a universal set. Usually universal sets can be represented U. Universal set can be represented as a capital U. For example, set of all integers. Okay, example, set of all integers. It means integers containing positive numbers, negative numbers as well as 0. Therefore, it is also one of the universal set. Then real number. Real number is also universal set. Okay. Universal set means the set of all the numbers containing basic set which is relevant to the particular constants. Okay. Now we discuss the exercise problems on the topic subsets, power sets and intervals. Here we have to solve the exercise 1.3 now. The first one question is make correct statement by filling the symbols subset or not subset in the blank space. Okay, before going to check the subset, first here always right side set is the larger set. Okay, always in that right side set it is the larger set. Now here it is the subset. Okay, here there is a main set and subset. It is called the larger, the elements may be equals to this set or other in some elements from this set are called the subsets. Okay, here 2 3 4 which is belongs to in larger set. Okay, hence it is subset. Okay, now check here BCD is the largest set. Okay, we have to check ABC is a subset or not. Here there is a element A which is not present in that set, therefore it is not subset. Again, X is a circle in a plane. Here there is a circle in a plane. I have considered a plane. Here XY plane. X is a circle in the plane. Here there is a circle in a plane. Then the main set X is a circle in the same plane with the radius. Radius 1 minute means wherever we draw the circle. Okay, in a plane wherever we draw a circle, it is of radius 1 unit. It is of radius 1 unit. But here X is a circle in a plane. There is no condition. It may be radius having 1 unit, 2 unit or more than 1 unit or less than 1 unit. Okay. Therefore, here this is the smaller set. This one is the larger set. Therefore, it is not a subset. Always right hand side is larger or equal sets. Therefore, it is subset. Now, consider the question number 4. X is a student of class 11th of your school. Here, consider a class 11th. Here, X is a student of your school. In your school, there are so many classes are there. It may be 10th, it may be 11th or it may be 12th. Okay, here school means it contain a 1 to 12th classes. Okay, here 11th is one class of this school only, that's why it is a subset. Okay, next question number 6. X is a triangle in a plane. Here there is a triangle in a plane. Then X is a rectangle in a plane. Here the set of triangles. Here there is a set of triangles. Okay, here X is a rectangle. Rectangle means it has 4 sides. Triangle means 3 sides. From this 4 side we have to make a triangle. Okay, when we take the line here, it is becomes triangle. Again I am taking line here, then triangle. Okay, from the rectangular plane we have to make a triangles. Therefore it is the subset. Then X is a equilateral triangle in a plane and X is a triangle in the same planes. Equilateral triangle, it is a type of triangle. Okay, equilateral means all sides are equal. Here X is a triangle. Okay, triangle, it is a triangle means it containing so many type of triangles are there. For example, isosceles triangles are there, salient triangles are there, equilaterals are there. Okay, but it has a set of triangles. It equilateral means it is the one of the type from the triangle. Therefore it is also subset. Then the last question is X is a even natural number. Then X is a integer. Integer mainly it contains positive numbers, negative numbers as well as 0. Here even natural numbers. Therefore the even natural numbers are 2, 4, 6, 8. This is also subset. Clear? Then we have to check the second question. Okay, here there is a second question. Examine whether the following statements true or false. We have to check they already given us statements. We have to check it is true or false. Here it is the main set and AB is the subset. AB is not a subset of BCA. AB, there is an element here also AB present. It is a subset, but they given not subset. Hence it is a false statement. Okay, it is a false statement. Again, the elements A, E. Okay, here X is a vowel in the English. What are the vowels in the English alphabet? A, E, I, O, U. These are the vowels. Therefore AE is the subset of this set. Yes, this one is the true statement. Again we check 1 2 3 subset of 1 3 5. No, because the set containing 2, but here there is no 2, it is false. Then single set A is subset of ABC. Yes, it is a true set. Here the set A which is belongs to ABC. Belongs means it's about elements. Okay, here A, B, C be a set, but not set is not present here, therefore it is false. Here subset is different as well as element is different. Okay, subset means we create another set. Here elements means the element means there is a object which is present in that set. Okay, therefore elements and subsets are different. Here x is a even natural number less than 6. What are those even natural numbers less than 6? 2, 4. These are only two elements. X is a natural numbers. 1, 2, 3, 4. It is the largest set. Therefore, it is subset. Hence, it is a true statement. Okay. Now, the third condition. Let A be a set containing the elements 1, 2, 3. Here, in that set, there is another one set. So, I will consider the set as an element X. Okay. Here, I am considering the 3, 4 as an element X. Then I will rewrite it as Z, that is 1 2 x 5. Okay, this is set. Now we check the condition. Which of the following statements are incorrect and why? Okay, when we have to check the statement correct or incorrect and give the reason for that statement. Here 3 4, it is a set containing 3 4 is subset of A. Yes, obviously it is a subset or not. Here there is no elements. Okay, it is a incorrect statement. Okay, here 3 4, it is an element of X. It is not a set. Therefore 3 4 is not a set of subset of A. Therefore it is incorrect. Now check the current. 3 4, 3 4 are the elements X. Okay, there is an X containing the elements 3 4. Hence it is a correct statement. An element. I replace 3 4 by X. Therefore it is a correct statement. Then question number 3. Okay, question number 3 means there is a replace 3 by 4 as a X. Okay, so a set containing the X, it is a statement is correct statement. Okay, I will replace 3 by 4 by X. Therefore then the set containing the elements X which is belongs to A, it is a correct statement. Then here an element 1 which is belongs to set A. Here there is an element 1 which is belongs to set A, it is correct statement. 1 is not a subset, it is an element, therefore it is not a incorrect statement. Then question number 6. The set containing the elements 1 2 5 is subsets of A. 1 2 5. Yes, it is the subset. Here first have to think the elements which are present in the flower bracket, it means set. The elements are not written in terms of in the flower bracket, it means element. It is clear? Okay, the elements are written in the flower bracket, it is called set. The elements are not written in the flower bracket, it becomes element. Now it is clear. Okay, here 1 2 5 is subset of A. 1 to 5. Yes, it is subset of A. Again, 1 to 5 is not belongs to, because this is set, not a elements. It is incorrect. Then pi is belongs to A. Pi means null. Okay, null. There is no element. No, here so many elements are there. It is not a incorrect state. Here null set is subset of A. Okay, it is true, because every set has a null set. Okay, there is no elements in between there is no set in the set. Okay, null set is always subset of every set. Again, here the element null set is subset of A. Yes, this is also correct state. Now we check the next questions. Okay, here there is a question number 4. Okay, exercise question number 4. Write down all the subsets of the following sets. Here there is a one element, so number of subsets are 2. First we have to calculate the subsets. Here there is an element 1, therefore 2 to the power 1 is 2. Hence it has two subsets. One is itself a subset and another one is the empty sets. There are two subsets are there. Next, for this one, here set containing the two elements. What are those? 2 to the power 2, 4. So it has 4 subsets, because they say all the subset. There is a condition is all the subsets, means there are 4 subsets are there. What are those? First one is empty set, and again itself a subset. Then A, singleton A, singleton B. Singleton means and set containing only one element, then it is called a singleton. Okay, here there are 3 elements are 2 to the power 3, therefore 8 subsets are there. What are those? Empty set, and again that set 1 2 3 itself a subset. Then singleton 1 2 3, 1 comma 2, 2 comma 3, 1 comma 3. Okay, 1 2 3 4 5 6 7 8. There are 8 subsets are there. Again, next question. Here there is a null set. Null set means there is no elements in the set. Therefore 2 to the power 0, it is 1. Okay, null set is itself a set subset, therefore there is only one element, one subset is there. Okay, then question number 5. How many elements has a power set of A? If A has no elements, it means only how many elements has power set of A? Power set of A has only one element, because n of power set of A is equals to 2 to the power 0. Therefore, it has only one element. Then, write the following in a set builder form. Okay, set builder form. They given condition, we have to write the set builder form. The general set builder form can be written as: first write the flower bracket, then an element x such that x is belongs to the real number. Okay, then we have to write the interval -3 x 0, then close. Now we have to write the symbol. Now here both having the open interval, therefore both having less than condition. Here this interval means less, this interval represent here. Similarly for this one, x such that x is belongs to real number, then first write the elements numbers 6x 12. Here both having the close interval, therefore less than or is equals to, less than or is equals to. Here x is belongs to the real number and 6x 12. Here there is an open interval. Open interval means only less condition. Here close interval, it means less than or is equals to. Next, x such that x belongs to the real number, then minus 23 x 5. Write the symbol here. There is a close interval, therefore it containing less than or is equals to. Here open interval, that is less than condition. Next, question number 7. Question number 7. Write the following as a intervals. Now we have to write the interval for these conditions. Here first write the numbers 4, 6. Here less condition, open interval. Here less than or is equals to close interval. Next, minus 12, minus 10. Here less than condition, therefore open interval, less than open interval. 0 and 7. Here less than or is equals to, so close interval. Here less than condition, therefore open interval. 3, 4. Both having the less than or is equals to condition, that is both having the close interval. Up to this much I solved the exercise problems. There is a 8th and 10th questions containing the universal set. Okay, just they given about the universal sets. Okay, up to this much the concept as well as exercise completed. If you have any doubt, write it in the comment section. I will reply. Okay, thank you for watching my video. Please, if you like my videos, subscribe my channel as well as send to your friends circle. It will helps to them. Okay, thank you.